Hello, my peeps. Welcome to another wacky and zany Algebra Nation podcast. Today's podcast / video will cover your workbook, page 85 and page 86. Giddy up.
Now we're going to solve a system of linear equations with algebra. But we have two methods. With these two methods, it's going to be useful because graphing is a good way to see a solution, but it's not easy to see with like fractions and decimals. Our two methods are substitution and elimination. Substitution, we're going to substitute, and elimination, we're going to eliminate. It is important, though, to know what to use so you can get it done as quickly as possible. Meaning, when you look at a system of linear equations, which method is preferred? Substitution is used when you can easily see and solve for a single variable, meaning when the variable of the coefficient is 1. Like looking at this system, which variable is easy to solve for? Little x by itself. If you see a little x or a little y, an x with a coefficient of 1 or a y or any variable, that I would use substitution for. Then there's elimination. Elimination, you should recognize one of two things. You would use elimination when you see the same variable has the same coefficient. 45 and 45, that's a match. You see 45 and 45, or 7 and 7, or 2 and 2, I'm going to use elimination. Or when you see the coefficient is a multiple. Not 2 and 7, but rather 3 and 6. 3 times 2 gives you 6. So if you see elimination with a match or a multiple, again, I'm going to use elimination. Overall, though, on the test, they will not tell you which one to use. Both work every time. You can use substitution for everything and elimination for everything, but some problems are easy to solve. They're better to solve with substitution, and some are going to be easier with elimination. So with that in mind, on this next page, I just want you to identify which method is preferred. Like, for example, given this one, would I use elimination or substitution? I would recommend, there's a single y by itself, a y, a 1y, I would substitute in this case. In this next case, I see a match. I'm going to use elimination. And in this last case on this page, I see a multiple. So I'm going to use elimination. If you see a match or a multiple, go for elimination. If you see a single variable, a y or an x or any other letter they use by itself, then I would use substitution. Which actually, to solve these, I'm going to break it down to 3 categories. I'm going to call it substitution, elimination match, and elimination multiple. And hey, substitution has a video, elimination match has a video, and elimination multiple has a video. So stay tuned, get ready to click.
Lucky you. You ready for a brain break? Too bad. Here goes. I think this guy just got a score from the crazy math teacher, and that's right, baby. He got a 399 or higher, doing the robot dance with a little bit of spiking there. That can be you if you get a 399 or higher. Back to work.
Solving a system of equations by substitution. To solve a system of equations by substitution, you have to notice that at least one of the equations has a variable with a coefficient of 1, meaning x, y, or any other variables that they're using in that system of equations. In this case, I see y, which means 1y, which also means I want to get it by itself. I want it to be y equals. And in order to do that, I'm going to go ahead and subtract the 2x over to the other side, giving me y equals negative 2x plus 4. Because now I have y equals, and the other equation has a y, I can substitute in negative 2x plus 4 into this y because that's what y equals. I would have 3x plus 4 times y, which is also equal to negative 2x plus 4, equals 1. And that's how you substitute one equation into the other. Again, given these two equations, I have the top equation solved for y, and I have a y in the other equation. Y equals negative 2x plus 4, and I can go ahead and plug it into the other equation for y, and now put it all together, and I have one equation with one variable to solve for, x. So here we go. And how are we solving? Distribute, combine like terms on each side of the equal sign, move your variables to one side, your numbers to the other, and divide if needed. Remember that? Start by distributing 4 into the parentheses. I have 3x. 4 times negative 2x would be negative 8x. 4 times 4 is positive 16 equals 1. Next, combine like terms on either side of the equal sign. I can combine 3x minus 8x will give me negative 5x plus 16 equals 1. I already have my variables on one side. Let's get our numbers on the other by adding and subtracting. The opposite of adding 16 would be subtracting 16. I leave negative 5x alone. 16 minus 16 is 0, so that cancels. 1 minus 16, you need to break out that calculator. 1 minus 16 will give you negative 15. Whew. And then lastly, divide both sides by negative 5. Negative over negative is positive. Over here, the negative 5s just simplify. And you get x equals 3. Am I done? No, because that only solved for one variable, x. Now I need to go ahead and plug back in to solve for y. You can plug back into either equation. In fact, if you have time, plug back into both equations and make sure you get the same answer. Otherwise, you might have done a math error, so you really want to make sure to check your work. If I plug back into let's say the first equation, I have 2x plus y equal to 4. Or I could even plug into this equation, that way I don't have to solve anything else out. Either way, we should get the same answer. So if I was to plug back into the original one, 2 times 3 plus y equals 4. 2 times 3 is 6. Subtract the 6 over, and y equals negative 2. And if you have more time, and me out of the way, hey, you can go ahead and plug them both back into the other equation and make sure that it goes ahead and has the left and right hand side equal to each other. Meaning, going all the way back to this equation and getting 3 times x we saw is equal to 3, plus 4, y is equal to negative 2 equals 1. 3 times 3 is 9. 4 times negative 2 is negative 8. And 9 minus 8 does equal 1. So our answer is x is 3, y is negative 2. X is 3, y is negative 2 would be the solution for this system of equations. Let's do another. So the directions here would be solve, and you're going to solve for, in this case, x and y. Either equation, it looks like, I can go ahead and solve for y. Doesn't matter which one. I can solve the top equation for y equals. I could solve the bottom equation for y equals. Let's say I solve the top equation. That means I would add the x over to the right-hand side, giving me y equals positive x plus 1. And I'll substitute that into the other equation, 2x plus y, which is just going to equal now x plus 1 equals negative 2. If you decided to solve the other way, go ahead and post your work on the wall, and we can check to see that we all got the same answers at the end. So from here, distribute. There's really, remember, a 1 in front, or whenever you have addition with parentheses, you can remove the parentheses because you're just multiplying by 1. combine like terms. 2x plus x will give me 3x plus 1 equals negative 2. My variables are already on the left. Let's subtract the 1 over to the right. 3x equals negative 2 minus 1 is negative 3. And then lastly, divide both sides by 3. Negative 3 divided by 3 will give you negative 1. So that's x. Now you plug back in and solve for y. So in this case, I'll plug back into the equation that's already solved for y. I'll get y equals x, which is negative 1, that's what I solved for, plus 1. And negative 1 plus 1 will give you 0. So that means x is negative 1 and y is 0. X is negative 1 and y is 0. What if they ask you to write it as an ordered pair, as a point? You could write it as negative 1 comma 0. Remember, you want to follow alphabetical order. X comma y, x then y. X is negative 1, y is 0. I could have also plugged negative 1 back into either of the original equations, and I still should have got 0 for y. And if you have time, go ahead and give that a try and post your work on the wall. We can all check it out. Your turn.